Hello, geometry students. Mr. Zacek here, back and better than ever. We're going into just some more examples here. It's continuation from um, lesson 2-1, and we're going to get into a little more, creative types of proofs here. So some things that are going to require a little different kind of thinking here. And in these examples, we kind of want to begin with the end in mind. So we're trying to prove here that KQ bisects JP. Well, if JP was being bisected, what would be true if that was bisected? Well, what would be true is that here's what we have to show, or what we got to get to, that JM is congruent to MP. So that's, if we could get to there, we can go from there to prove the thing that we're trying to say. Well, how do we get there? Well, let's see what we're given and kind of let's go from that standpoint. All right, so we're given that JK is parallel to PQ or QP, and that JK is congruent to PQ. Okay, now, when you have parallel lines, what you want to think about parallel lines is parallel lines unlock angle relationships. Okay, parallel lines unlock angle relationships. So specifically here we have some alternate interior angles. Angle J would be congruent to angle P, and then angle K would be congruent to angle Q. So then we can prove the triangle's congruent by angle, side angle, angle, side angle. So if we go angle, side angle, what can we do to get JM congruent to MP? We can do that by corresponding parts of congruent triangles, and then we can prove the thing that we're trying to prove. Now, some of you are looking here and you go, hey, wait a minute, Mr. Zacek, couldn't we do angle, angle, side if we have vertical angles? Yeah, we can. You could do vertical angles in this case, but I'm going to do it this way just to give you some variety, but you're not wrong at all if you want to do vertical angles. So let's go ahead and write this out. So we're given here that got the parallel side, we got the congruent side. All right, that's given. What did we accomplish there? We did a side congruent to a side. So step 2 is, I'm going to say that angle K is congruent to angle Q, and angle J is congruent to angle P. And that's because the lines are parallel. And so the reason is going to be if two lines are cut by a transversal and parallel, so it's cut by a transversal. This is not a such that one. This is the fact that they're parallel and parallel, then alternate interior angles are congruent. Angles are congruent. So that's an angle pair, congruent angle, congruent to an angle, angle congruent to an angle. And again, in terms of the reason, so now I can say triangle, let's call the first one, let's go maybe KJM. If we did triangle KJM, the next one has to be triangle QPM in order to get the corresponding parts. Now, the reason is not the order that those things come in your proof. The reason is the order that they are on the triangle. So this is angle, side, angle, congruent to angle, side, angle. That's a mistake sometimes people make as well. I wrote them out in my proof. I did the side first, so does that mean? No, it's how is it on the diagram. Okay, so now we've proven that the triangles are congruent, so therefore we can prove that their parts are congruent. So JM is congruent to MP. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent, or CPCTC. It's hard to say that fast. Okay, now this makes me think of like some kind of fighter guy. CPCTC. Yeah. Anyway, now that we've said JM is congruent to MP, we can say KQ bisects JP. And here's why. If a segment divides a segment into two congruent segments, then it is a segment bisector. So we're just kind of flipping around that reason before in our proof terminology sheet where we said, you know, it's a segment. If it's a segment bisector, then it divides the segment into two congruent segments. And here we're saying, well, if it divides it into two congruent segments, then it is a segment bisector. And again, the last step is always the thing that we're trying to prove. So we've got that there. Our parts came after our congruent triangles. Okay, key point there. So again, some different kind of, we're gonna access our creativity here, think a little more deeply as we go through these. All right, now here again, begin with the end in mind. We're trying to prove, here's where some highlighters might help you. We're trying to prove that AB is parallel to DC. Well, what proves that lines are parallel? Well, if we could prove that the angles are congruent, maybe the alternate interior angles, if we could prove that angle BAC was congruent to angle DCA, then we could get from there to parallel. Okay, well, what are those? The angles are parts of triangles. So how do we get parts of triangles? We get the triangles, we do their corresponding parts, then we can get to parallels. Kind of same process we had as last time. So let's see what we've got going on here. DAC, this angle, is congruent to BCA. Now, the reason those are not alternate interior angles is the arc doesn't touch the parallel side and the transversal. See, it touches those non-parallel sides. If we had given the other pair of angles, we could go right to the end here. Okay, and then AD is perpendicular to DC. I'm going to call this angle 1. And CB, I'm going to call this angle 2. We've got some right angles. Okay, and then we got a common side here by the reflexive property. So our plan would be angle, angle, side. And again, it's angle, angle. The side is not included between the two angles that we know. Okay, so if we get the triangles, then CPCTC to get the parts, which gets us to the parallel lines. Okay, so let's go ahead and do this out. So we got angle DAC congruent to angle BCA. Okay, that's an angle congruent to an angle. And then we've got AD perpendicular to DC, CB perpendicular to BA, and that is given. Okay, so part of our triangle plan is accomplished. What do we know about perpendicular lines? They form right angles. So we can say angle 1 and angle 2 are right angles. What's the reason? If two lines are perpendicular, then they form right angles. If two lines are perpendicular, then they form right angles. If two lines are perpendicular, then they form right angles. Okay? from our proof terminology sheet, we know the next thing we can say is angle 1 is congruent to angle 2, and the reason is all right angles are congruent. Okay, so we set another angle congruent to an angle. Now we got to get the side. 2 parts of our plan is done. So the side is going to be AC is congruent to AC, and that is by the reflexive property. Okay, one of our freebies. All right, that allows us to say that the triangles are congruent. So I can say that triangle ADC is congruent to triangle CBA. And the reason for that is that angle side is congruent to angle side. Okay, now that the triangles are congruent, we can say that their parts are congruent. So angle BAC is congruent to angle DCA, and I'll mark them up here. Now I didn't want to put this earlier, but it's those ones and those ones. I didn't want to mark that earlier because I didn't want to, that's not a given, so I don't want to confuse that. And that's corresponding parts of congruent triangles are congruent, or CPCTC. Now, since those 2 angles are congruent, those are alternate interior angles, so we can say that AB is parallel to DC if 2 lines are cut by a transversal such that alternate interior angles are congruent, then they are parallel. Okay, so again, what did we need? We needed to prove parallel. How do we prove parallel? We get congruent angles. How do we get congruent angles? We get congruent triangles, and we're starting to see, hopefully, how the puzzle pieces fit together in doing these different types of more complex proofs. Okay, let's go ahead and move on to the next one now. All right, so we're moving on here to question 3, and in this scenario, again, I think it helps to kind of begin with the end in mind. I'm going to start off with, or what are we trying to prove? We're trying to prove that AB is congruent to CD. All right, now what I notice is that's a part. So probably if we could prove triangles congruent that those are a part of, that would be a helpful thing. So one of the ways we see is we've got, let me get my red pen here. Doesn't need to be red, but so I've got, excuse me, angle 1. I'm going to call this angle 1. Here, perpendicular lines form right angles. And then over here, I'm going to call this angle 2. So we've got those. Then we've got BE and DF. Okay. Now this is a little bit different because I'm going to use a highlighter here to show you. Now it says AF is congruent to CE. And what you notice is those sides are a little bit longer than the triangle. I'd really like AE to be congruent to CF. While we can use subtraction to get those 2 segments there. And that would end up allowing us to prove that the triangles are congruent with side angle side. And then once we have the triangles congruent, we can do CPCTC. So let me go ahead and show you what that looks like. And all right, so statements, reasons, got lost in the printing. All right, so my plan is to prove triangle. Let me just kind of highlight what those triangles are. Yellow highlighter, come back. My plan is to prove this triangle and this triangle congruent using side angle side, and then their parts are congruent using CP/CTC. And I'm going to use subtraction here in this one. Okay, so BE is perpendicular to AC. DF is perpendicular to AC. All right, given, and I'll bring the other givens in as well. Okay, so BE, actually let me only bring one of the other givens in right now, and I'll bring BE is congruent to DF. I'm going to bring the other given in later. You'll see why. Okay, so side congruent to a side, so that's part of the triangle plan. Let's go get the angles. Angle 1 and angle 2 are right angles. So the reason is, if two lines are perpendicular, then they form right angles. If two lines are perpendicular, then they form right angles. If two lines, okay, you get it, perpendicular, then they form right angles. All right, form right angles. And then we can say that those angles are congruent. So angle 1 is congruent to angle 2, all right, which is all right angles are congruent. Okay, now I'm going to deal with that other segment. So I'm going to add another given here at this point. And again, it wouldn't have been wrong to do it before. I just want you to see it in here. So AF and CE. All right, and that's given. Okay, and again, AF and CE, the problem is they're longer than the segments. So we need to subtract. What are we going to subtract? Well, we're going to subtract EF. EF is congruent to EF, which is the reflexive property. So the reason I waited to bring that other given in is just visually so it's a little bit easier for us to see what's happening here. So now we're going to subtract. AF minus EF would be congruent to CE minus EF. Or what's the result when we subtract? Well, when we take EF off of AF, we're left with AE congruent to FC. So that's or AE congruent to FC. All right, and that is the subtraction property. Okay. Now, that was the other side congruent to a side. And the reason why like step 4 and step 5 weren't the side is they weren't the sides on the triangle that the two triangles we want to prove congruent. Okay, so we're going to have triangle ABE is going to be congruent to triangle, excuse me, ABE is going to be congruent to triangle CDF. Okay, so triangle ABE is congruent to triangle CDF, and that's by side angle side, congruent to side angle side. And then our last step is the thing we're trying to prove, which is AB congruent to CD. Okay, so AB is congruent to CD, and that's because corresponding parts of congruent triangles are congruent. So we've got the triangles and now their parts are. All right, so we're just kind of adding some different tools to our toolkit here and scenarios of what we can possibly do. All right, our last question here in this lesson is the construction of a line perpendicular to line L through line P is shown. Explain why you conclude that CP is perpendicular to L. Okay, how can you use congruent triangles to justify your answer? Which lengths or distances are equal by the construction? Well, part of what we know is that this side and this side are congruent. Okay, so we can prove that, based off of the radius there, we've got those two sides that are congruent. And then we can show here that this length and this length are going to be the same, because we're doing that with the same compass setting when you construct that. All right, so if we have those two things and then we have a common side here, we are creating two triangles that are congruent to each other. Okay, now part of what makes this work is, okay, so what we can do at this point is, what this approach allows us to do is, it allows us to say that the triangles are congruent. So we've got triangle, I'm not going to do the whole thing out, but I just want to give you kind of the idea. Triangle ACP is congruent to triangle BCP by side, 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 congruent to side, side, side. Okay, now what happens then is angles 1 and 2 have to be congruent to each other by CPC TC. Okay, well, we also know that the measure of angle 1 plus the measure of angle 2 has to equal 180 because they're a linear pair. So if the angles are congruent and the angles form a linear pair, the only way for the two angles to be the same and to add up to 180 is that they both have to equal 90. So the measure of angle 1 has to equal 90, the measure of angle 2 has to equal 90. So it's like, if two angles are congruent and form a linear pair, okay, then they are right angles. Okay, and so therefore CP is perpendicular to AB. Okay, because why? Well, because the two lines intersect to form right angles. Okay, so that's not a super formal proof, but just to kind of give you an idea of how the justification for that construction of how it comes up to be perpendicular. Okay, so a little bit of a longer one here, and definitely some challenge in thinking about these questions. So please ask and keep on asking. All right, we're trying to build the toolbox, show you different things. We can't show you every possibility, so we got to really kind of dial in on learning how to use the tools. All right, good luck. See you soon.